Hello folks and welcome to Oxygen Not Included. So today's video is going to be doing a series of experiments using this game's engine to see how things react, particularly how duplicants react, to certain circumstances, and to test out a few different theories that I have. So the general idea for this video series is that it's going to be focused kind of based on the scientific method. I'm going to present a theory. I'm going to test that theory, see how it works in the game environment, and go from there and analyze my results. Now keep in mind, this is not going to be a proper scientific video. So it's not like, well, it's not going to be like as far as using proper science. It's using game science. So all of the things that happen within Oxygen Not Included are what's going to be included in this video. So the first of the experiments that I'm planning to do here is testing two different groups of gases, hydrogen and carbon dioxide. I currently have an 8 by 8 area with the whole area about 1,050 grams of hydrogen. I have the exact same for carbon dioxide over here. The only difference is there is a slight difference in temperature. I'm not exactly controlling for that, so the experiment may be a little off as far as that goes. I don't know if that's taken into account. But the theory is that by eliminating this little bunker tile, both of these gases will eventually equalize in the same amount of time. Now, to do all of this, I'm going to be utilizing a little countdown just to show it off, and hopefully my theory is correct that they will equalize in the same amount of time. If not, it'll be worth analyzing. If they don't, I would guess that the hydrogen would equalize first, given that it is a lighter gas and should theoretically move quicker. We shouldn't have anything where the carbon dioxide is more centered to the bottom, and then like there's nothing up here. I don't believe that would happen. I believe it will equalize throughout the whole area, but let's test it out and see how we do. Go over to destroy, make sure this is set to 1 block, and I will simply destroy the 2 central blocks here, and same over here with the carbon dioxide. The timer is set, so let me go activate that. Resume, and then I will unpause the game. As you can see, both the hydrogen and carbon dioxide are starting to filter down into the lower area where there is vacuum. And already at the very bottom, you can see that both gases are gradually starting to fill up. So we'll accelerate this to medium speed. See if we notice any particular changes. As far as doing, well, let's pause it for a moment. Let's compare the lower right hand corner of hydrogen, which is 154, and the lower right hand corner of carbon dioxide, also 154. So as far as we can tell so far, they're both flowing at the same rate. So theoretically, my theory is going to be correct, that they will balance out the same. Let's speed it up again to fast speed. Allow it to flow a little bit better. Now, one thing I will say is that hydrogen is at least easier to see than the carbon dioxide. But at the very least, we do have our little tooltip providing us information. Now, the gases, since they both started at 1050, should equalize around like 525. Give or take, probably a little bit less, given that these 2 blocks as well now exist. It does appear like the equalization is a little bit going a little bit slower now at this point. If we pause it and look at it again, Hydrogen at the bottom right corner is 476.9, and carbon dioxide 476.3. So not much of a difference. It could very well be just the difference in simulation speed, for example, which, you know, makes things a little bit interesting at times, I suppose. Now, one other thing I should probably look at is the top right. So the top right-hand corner, well, actually, let's look at the top left, since that's the complete opposite of the lower right that we were looking at. So for hydrogen right now, it's 548.3, and for carbon dioxide, 548.8. So that small difference still exists, and let's see, is it an exact difference of 5? It is an exact difference of 5. Okay. So 0.5 grams is the difference between the two areas. Not entirely sure if that means anything. It could be a difference in the hydrogen like I was suspecting, but it's such a small difference that it's really hard to say. Now the gas still hasn't really equalized out yet, but I think we can probably say that it's close enough, because even when the simulation is running, there are still small differences. But I think that naturally occurs with the gases. There's something in the simulation that keeps the gases kind of moving around. Although at the bottom right-hand corner, it is still going up. So you know what, let's accelerate it a little bit more and wait until it either stops going up or down, or well, pretty much stops going up and down, or just like hovers between the areas like it is up in the central area. So we're about almost 6 minutes in. I will pause the countdown as it is right now, because I think we're about at the point of calling it. The gases are still equalizing, but very slowly, and they are about the same on both ends. As far as the overall, I guess, analysis of them, between the hydrogen and carbon dioxide going into a vacuum, they do seem to go at the same rate. There was a 0.5 gram difference for much of the time where they were traveling to the other end, but I'm not entirely sure if that's something that can be attributed to simulation speed, or if there is an actual difference between the carbon dioxide and the hydrogen, and it's just so small that it's really only represented by 0.5 grams. So for the purposes of my experiment, I'm going to say that my theory was relatively spot on, that they would equalize at the same rate. The second experiment that we're going to be doing today is going to be analyzing what happens to a duplicant when they fall into liquid oxygen. Now, liquid oxygen, as you can see, is around negative 198.7 degrees Celsius. I think there's actually a way to look at Fahrenheit here. Yes, there is. Haha. America for the win. All right, there we go. So, negative 325.7 degrees Fahrenheit. Very cold. The theory, or the question, I guess, is, does a duplicant turn into ice when falling into liquid oxygen? My theory on this question is that more than likely the duplicant is just going to die, that they're not going to have any special effects or anything like that. But I could be wrong, and they may have implemented it here. So let's go ahead, test this out. We're going to destroy the blocks underneath her, going 3 things wide just to make sure that she properly falls in and doesn't like escape over to the other side. You know what, we'll just completely destroy everything that she could potentially jump onto. Alright, so she's gonna fall in, and let's see what happens. So she automatically becomes idle. She's in chilly surroundings. She's got hypothermia. She's received hypothermia relatively quickly. But as far as her death goes, I want to say she's more likely to die from drowning than anything else. At least that's the way it appears so far. Let's see, her current breath is down to almost 50%. Body temperature is falling, though, quite rapidly. I suppose perhaps I should try to give her an area to get up to. Just a little bit. Still, it's not going to be the best test, but at the very least, it will still keep her in around 300 degrees. Or negative 300 degrees. But she can breathe now. Body temperature is still falling, though. Now, any normal human would be completely dead at this point. Body temperature keeps going down. But it is actually... I should probably keep her hold to make sure that I don't accidentally destroy her. Alright, put her like that. That way she's still in the wetness of the liquid oxygen to keep the body temperature going down. Alright, body temperature is now at a negative 2 points, 3 points. Yeah, it's bad. So any human would be completely dead by this point. However, Liera here, who we're using, she's still alive, surprisingly. I will say I would have thought that the duplicant would have been dead by now. That more than likely the temperature would have frozen her, and that she would have just died. But that does not seem to be the case. So duplicants can go into being very cold. Now she is burning through quite a bit of calories. I believe anyways. Actually, it could just be the natural amount of calories that she goes through. It may not be, let's see. It just appears that stress, current environmental exchange. As far as I can tell, all of these things are just making her stressed or hurting her attributes. And now she's expressing herself. But she no longer has hypothermia somehow. So apparently duplicants can reach a point where they surpass hypothermia. She's still cold, but she's not sick anymore, which is very odd. Well, I suppose the big question ultimately comes at what point is she going to die? How low is her body temperature going to get? My guess would be at this point she's probably just going to die because of running out of calories. So let's speed this up. See just how low her body temperature goes. Any of the carbon dioxide that she's breathing is automatically solidifying, which is very interesting as well. Because this whole area is negative, well, the bottom area is negative almost 300. Now, one thing that'll be interesting is her bladder is at 100%. She has not wet herself yet, though. So I imagine it will be happening soon. It'll be interesting to see exactly what happens with that. You know, does it automatically become frozen, polluted water? Now, why is she saying low oxygen? The air is thin in this area. Oh, it is thin. So what must be happening? She's actually using up all of the oxygen in this area that's in gas form, turning it into carbon dioxide. And the heat isn't enough to turn this... Oh my! So what did we get there? Polluted ice. Alright, that's very interesting. So yeah, I didn't expect this. I think she's actually, before she gets to dying of hunger, that she's actually going to suffocate. Because as you can see now, the oxygen here is down to about 50 grams. The temperature is still so cold that the oxygen is remaining in a liquid form. And so now she's going to suffocate. Oh, this is like, you know how it's water, water everywhere, but not a drop to drink? Well, oxygen, oxygen everywhere, but not nothing to breathe. This is a very interesting thing. I didn't expect that this was going to be how she goes. And there she goes. She did. Alright, we have one more experiment to do. So let's go do that and see what happens. The final experiment that we're going to be doing here today is, well, the question for this experiment is, does magma destroy algae? Given what we've seen from everything else so far, especially in these experiments, I would say absolutely it will destroy the algae. Now, question obviously becomes, what's going to come from that algae? Now, I know that there is like an elemental carbon. I'm guessing that the carbon is going to come from this algae, so pretty much what's going to happen is the magma is going to go in, it's going to burn through all the algae down here, and it's going to leave carbon behind. Whether it's in the form of gases or what, I'm not entirely sure, but that's my theory. So what we're going to do to test this, we are going to destroy these blocks of magma, let it rain all down onto the algae, and see what happens. So let's go ahead, get started here. So the magma falls onto the algae, and the algae becomes dirt of all things. Okay. I guess that makes sense. It's kind of like carbon. Composite of solidified volcanic rocks. Now, does anything happen as the temperature goes up? Well, we can speed things up a little bit. It is melting through, so it's turning more of the algae into dirt, and then the dirt is becoming sand. Interesting. Now, is there a glass available in this game? Like, can sand become glass? Maybe? Well, as we're waiting here, let's take a look. Go back. Go to solids. There is a glass solid. So it is possible, I believe, that sand could become glass if it gets hot enough. So let's further increase the speed a little bit. The magma hasn't really destroyed anything yet, though. Temperature is still going up, because the magma is still at a good 2,700 degrees Fahrenheit. But yeah, this is not exactly going as I'd expected. I didn't expect the dirt to become glass, or to become sand here. Now, I do expect the sand to become glass. If that doesn't happen, I would be very surprised. Oh, here we go. Some igneous rock is forming from all of this. Oh, that's because of the magma. The magma is actually cooling down and becoming the igneous rock. Okay. So to further let this... Okay, looks like it completely stopped. So the air temperature is definitely very hot. And it's still seeping through, but yeah, it didn't completely finish the process. So you know what? Let's help finish it. Got molten glass we could put down, but no, we're going to do magma because that seems to be the best one. And we'll fill up this whole area and let that seep in. See what happens. I could even further increase the temperature of the magma as well. Put one more group up here that has a much higher temperature, up into the 4,000 degrees Fahrenheit range. Now, even at 2,000 degrees Fahrenheit, the sand still hasn't turned into glass. Is there, let's see, specific heat capacity. Well, the melting point is 3,000. So maybe that's what we have to get it to for it to actually turn into glass. So I guess the next step is obviously to apply the heat ray. Now what happens when you further increase this? There is some measure of gases coming out, but so yeah, pretty much we have molten glass and we have magma here. So it didn't exactly go as I planned. I had hoped, or at least suspected, that the algae was going to become carbon. Did not happen here though. Unless it became carbon dioxide through all of it that I somehow missed, which is a possibility. It could be. Yeah, that was an interesting little experiment though, to see what happens with the magma and the algae. I did not expect the algae to become dirt than sand. Dirt I can kind of see, sand I did not. Kind of makes sense though, perhaps. You know, the particles for sand are probably within most dirts. It's just, you know, not exactly there. Not entirely sure how the whole process of dirt going and becoming sand works though. Like, is that something, like, is there another element going on around here? I'm not entirely sure. But yeah, so that is it for my experiments. Hopefully you enjoyed this video. It definitely had some interesting elements to it. If you enjoyed this video, and particularly if you play Oxygen Not Included, and you have other questions about, you know, potential scientific experiments that we could do, leave them in the comments below. Let me know what you would like to see. I thought I was rather entertained by some of the stuff that went on here, especially how Liara, during the liquid oxygen tests, did not actually die from, well, definitely she didn't die from anything that I expected. She lost all of her breath. So thanks for watching, folks. If you haven't already, be sure to subscribe. Also follow me on Twitch, where I do my streamings every Wednesday, Saturday, and Sunday. And I hope you enjoyed. Thanks for watching, and I will see you all later.